Good evening. Today we're going to discuss the periodic table of elements. People hear the term periodic table of elements and their mind goes crazy. They think of, oh, all these chemicals, it's so confusing. But really, what the periodic table of elements is there for is to be a tool for you to use. And once you understand the rules of how the periodic table of elements is set up, it becomes much easier to understand what's going on. It's a way that we can keep track of all the different elements, and we can organize them based on similarities in their structures. Elements on the periodic table are organized in a couple of different ways. If we start at the top left-hand corner and go from left to right, you'll notice the boxes are numbered in order of increasing atomic number. But more importantly, the elements are put into groups or families which go in the columns straight up and down based on their chemical and physical similarities. Their physical similarities dictate how they react chemically, and we'll get into that in a moment. And when we say physical structure, we really mean the number of valence electrons they have. And what you notice here is I put an E with a negative sign, and I'm going to use that symbol to indicate the word electrons from now on going forward. Now, in addition to being organized into columns, which we call groups and families, they are also arranged from left to right into what we call periods based on the number of electron shells or orbitals that each atom has. We're going to take a look at a couple of different periodic tables in order to explain the different concepts we're discussing here. We're going to show you how they're arranged by atomic number, what it means to be in a specific family, and what it also means to be put into a particular period on this periodic table. Here we see the different groups of the periodic table. I've highlighted 8 of these different groups because those are the groups that we're going to be looking at in more depth this year as we get deeper into the chemistry unit. You have 18 groups or families going up and down across the periodic table, and we number them from 1 to 18. Group 1 is called the alkali metals. They are the most reactive metals on the periodic table. Group 2 is called the alkaline earth metals. They are the second most reactive metals on the periodic table. You may notice that these two words are very similar, alkali and alkaline. One of the ways that helps me remember that alkaline is the second group and alkali is the first group is that alkaline is a larger word than alkali and 2 is a larger number than 1. We're not going to get too much into groups 3 through 12, which we call the transition metals, this year. But you should know that they are metals and they do exist. There are 2 other groups on the periodic table that have special names. Group 17 are called the halogens. They are the most reactive nonmetals, and they like to react many times with the alkali metals or the alkaline earth metals. Group 18 are called the noble gases. The elements that make up the noble gases have a full outer shell, so they don't react with any other elements. The other 4 groups are named after the chemical that is at the top of each of their columns. 13 is called the boron group or family. 14 is called the carbon group or family. 15 is called the nitrogen group or family. 15 is called the nitrogen group or family. And 16 is called the oxygen group or family. So really you only have to remember 4 different names because you're going to have the periodic table in front of you all year. Earlier we mentioned that elements are put into groups based on their structural similarities and the number of valence electrons we have. So what does that mean? And what does each group number tell us? The elements in group number 1 all have 1 valence electron. So they all have a similar valence structure. Hydrogen has 1 shell with 1 electron. And you're going to remember this from when we went over how to build a Bohr diagram. Lithium has 2 shells with 1 valence electron. Sodium has 3 shells with 1 valence electron. Potassium has 4 shells with 1 valence electron in its outermost shell. So all of these elements in group 1, in group 2, you have 2 valence electrons in all of the elements that make up group 2. In group 13, they have 3 valence electrons. Group 14 elements have 4 valence electrons. Group 15 have 5 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. And group 18 has 8 valence electrons, with the one exception being helium, which only has 2 valence electrons, but its outer shell is full because it only has one shell, the K shell, which can only hold 2 electrons. So they are very unreactive, meaning they have a full outer shell, so there's no need to react with other atoms to fill their outer shells. Now here's a blank periodic table of elements. Now we said that the elements are organized in order of increasing atomic number. So if we start at the top left-hand corner, the element that has an atomic number of 1 goes here. Atomic number of 2 goes here. Then we drop down to the second period, and atomic number of 3, 4, 5, 6, you'll see it goes up to 10. And then it goes to the next period and starts at atomic number 11, 12, up to 18. And then you drop to the fourth period and you have 19 and 20. And then it goes all the way across. And you may ask yourself, well, why didn't they just go all the way across starting at 1? And the reason why they don't go all the way across starting at 1 and putting 2 next to it and then going all the way across is because they want to keep the groups and families together. That's why it has this weird shape. The reason the bottom 2 rows were removed was also to maintain the shape so that the atoms of elements in these 6 families can also stay together. So we know that they are very similar in physical structure and therefore react very similarly when it comes to their interactions with other atoms that want to fill their outermost shells. Also to remember is that these atomic numbers represent the number of protons of an atom, and each atom is identified by the number of protons. So maybe somebody asks you a question like, will an atom ever be discovered in between boron and carbon? And the answer would be no, because you can't have an atom with a half a proton. So no new atom will ever be discovered with 5.5 protons because it wouldn't exist. Here we have the periods indicated by different colors as well. And we number the periods starting from top going to bottom, 1, 2, 3, 4, 5, 6, 7. The 2 rows at the bottom have simply been removed from this area to maintain the continuity of the groups and families so that the elements with similar physical structure, meaning valence electron numbers, can stay together in the same column and row. The 2 elements that make up period 1 only have one shell, the K shell. The elements in period 2 have 2 shells. In period 3, they have 3 shells. In period 4, they have 4 shells. In period 5, all the atoms have 5 shells. And in period 6, they all have 6 shells. And period 7, all of these atoms have 7 shells. So the period's telling us how many shells an atom has. As we go from left to right across the periodic table, the atoms take on very different properties. The atoms on the left-hand side of the table are metals. And sometimes you'll see a darker line drawn, and it separates all of the metals from the metalloids and nonmetals. You notice a staircase right here, and that staircase indicates the separation between the metals on the left and the nonmetals on the right. So you should see that as we go from left to right across the periodic table, the elements change pretty dramatically from metals to metalloids to nonmetals. As with any periodic table, you're going to have a key or a legend. And the trick to really knowing what you're talking about and what you're looking at is to read that key. So on this particular periodic table, if we look at any element box, we're going to find, this one says lithium, so you'll find that it's telling you what the atomic number is, so therefore you're going to know the number of protons and electrons in a neutral atom. It gives you the element symbol, in case you need to look up to see what elements are in a compound or a chemical formula. It tells you the element name, and many times it tells you the average atomic mass, or it will give you its atomic weight, which is rounded off to the whole number. So many times the atomic weight like this might be rounded off to 7. Okay? And that number tells you the number of protons and the number of neutrons in an atom. So in order to calculate how many neutrons are actually in an atom, you would simply subtract the atomic number from the atomic mass. But we should know that already from a previous lecture. Let's take a quick look at a slightly different periodic table of elements. All the information is the same, but you just have to read the key to understand it. So each box on this particular periodic table gives you the atomic mass in the top right corner, the atomic number in the top left-hand corner, the element name, and the element symbol. It tells you on the left the period. Going across the top, it numbers the groups from 1 to 18 across the top. And you should know that each group number tells you the number of valence electrons of the atoms in it. So all the elements in group 1 have 1 valence electron. In group 2, 2 valence electrons. In group 13, you just have to remember, it's 3 valence electrons. 14 is 4, 15 is 5, 16 is 6, 17 is 7, and 18 is 8. So the Lewis dot structure for all the elements in group 1 is going to look like this. In group 2, it'll have 2 dots around it. That'll look like that. Group 13 will have a valence structure that looks like this, with 3 dots around it. 14 like this, 15, 16, 17, and 18. Just draw a couple lines in there to separate them so you understand which each one looks like. Okay, I hope this gives you a little bit of an understanding of the basics of the periodic table. If you have any questions, please feel free to ask.